So for our little assignment here, we did end up going over pieces on the front of this, but here's a reminder. On here, we're supposed to, on number A, we're supposed to write down the recursive formulas that describe each of them. The calculorama has a initial value. Let me write down. The Rama has a initial value of 5 million, and they have a growth rate of 0.5 million in a year. So that's going to be the common difference of 0.5. So the recursive function that goes with the calculorama, here let me underline it in red, is going to be a sub n is equal to a sub n minus 1 plus 0.5, because I'm just counting it in millions. And then I need to write down the initial value is 5. Okay, so that's the first one. The ComputerFest one starts with 2 million, and it has an income of 15% every year. And so when I write my recursive here, that 15%, that's becomes a multiplier if you're adding a percent every year, and your multiplier is going to be 1 point whatever percent it is, so 1.15%, and that's going to be the pattern equation, and then your initial value here is going to be 2. Okay, so there's part A. Part B, we need to write the explicit. Since I'm already in blue, let's get the ComputerFest one done. The function, since it's a geometric one where you're timesing by a number every time, it's going to look like the geometric function, explicit function form, which we've been using for a while. So 2 times 1.15 to the n minus 1 power. And I like to just kind of put that in parentheses to show that part you do first when you're calculating stuff. And then the calculorama over here on the left side is arithmetic, so it's going to follow the arithmetic function form. So my common difference in front of n minus 1, and then plus 5 there. So yeah, when you're on here we have n minus 1. You'll see often that they'll just put n. When you're deciding whether or not to put n minus 1 or n, you need to think about where you're starting, and you need to think about when you're plugging things in, or you're using your function, are you going to be plugging in where 0 is your start, or is 1 your start? Here I'm going to say that 0 is my start, and then after 1 year, that'd be the second term in the sequence, so you'd be plugging in 2 for the first year interest. Anyway, part C here, comparing answers in A and B. How are the representations similar? How do they differ? What's the relationship? What relationships are highlighted in each representation? Well, the recursive formulas highlight the pattern. What's the relationship between consecutive terms? So like here, this says that each term is the previous one times by 1.15. And here, the recursive says each term is the previous one plus 0.5. And so it just that one highlights the relationship between consecutive terms, whereas these representations represent, like, focus on just kind of like the relationship between the result and what number in the sequence it is. So you plug in the number in the sequence and you get the number back, like how many dollars. And so that's what the explicit ones are focusing on. And you make your own choices on the answers here. They're similar because, right, this one has 1.5 and 2, this has 1.5 and 2. This one has the 0.5 and 5, 0.5 and 5, so they got some similarities. They're different, just kind of based on their setup. Like recursive ones have 2 equations, explicit have 1. Those are all sort of things you can write here. D, explain why both companies are able to meet, if both are able to meet their goals. The net income of Computafest will eventually be larger than Calculorama. And that comes from basically this part here. When you have an exponent, and here in your base there is bigger than 1, that will increase, the rate of change is going to get bigger and bigger and bigger. This one follows an exponential growth, so it's going to look like that. This one follows a linear growth. So even though this one might grow slowly at first, eventually, when it gets over this part of the graph, it's going practically straight up. It increases really, really fast. And so just because of the fact that it's exponential, it's eventually going to overtake this one. And in what year will the net income be larger? To figure that out, like, you can write out all the numbers, and it's actually not very soon. If you plug it into a calculator, you can get a graph that looks like this. The red one is the Calculorama, and then the blue one's the Computafest. And you notice right here is when the Computafest is going to be bigger than Calculorama, and because it's right here, it's going to be bigger. And so it's that point right there. If you use your trace function, you can see that the point is the point 31.19-ish, and then 156.46. The x value is the term in the sequence. We need to round it up because we want the blue to be bigger. So this is going to be the 32nd term in the sequence. Well, if we're starting at count on year 0, that means the 32nd term in the sequence would be year 31. So that'd be 31 years. That's a long time in the business world. But yeah, eventually it'll catch up and overtake it. And at this point, Computafest is growing incredibly well in comparison to the other one. So there you go, first aid.